All right, we are back. We're 2 hours in, and I think we're having some good fun. I have been told that there have been a ton of questions on the chat, and so a big shout out to Jaime Rodriguez and Nisha Singh, who have been helping me out on the chat forum. So please, when you get a chance, give them a big thank you. They've been managing a ton of you out there and asking a ton of questions. So thank you to that for both of you. Okay, so as I mentioned, we talked about we compared Windows Phone and Windows 8 over the past couple hours. And we're going to switch gears a little bit, and now we're going to talk about how you can use some different patterns. We'll talk about view models, and then we'll dive into MVVM later. The next session is sort of a short one. And we're going to talk about the basics of view models, how to build view models at the very basic level. Basically, we're going to talk about data binding, not so much how to use data binding, although we'll talk about that too, but more how you can define data binding and why data binding is important. So we'll talk about the basics of data binding, how it works. We'll talk about what's going on under the hood, dependency objects, dependency properties. We'll talk about view models, and then we'll talk about iNotify property change and notify collection changed. And then at the very end, we'll talk about commands and commanding. It should be a shorter session, so probably only about half hour, and then we'll take a pause, and then we'll come back and talk about MVVM. So let's dive in and talk about data binding and what that is. So we talked earlier about building data models and separating your data models from your views and from your view models. Maintaining and synchronizing a data model with a view can be difficult to maintain and difficult to test. If you have a lot of code behind in your views, it makes those views harder to test. So the more you can pull out of your views, so you can build unit tests and separate those views from your view models, the easier it is to test and debug and maintain and all of that good stuff. Data binding is what allows you to synchronize the data that's displayed in a view with a data source. And that data source can come from any one of a number of different places. It can come from a database, a file. It can even come from a class. And view models is the case where it would come from a view model class. Now, each data binding has three parts. You have the binding source, which is where your data is coming from. You have your binding object, which is where your data is going to, typically your view. And then you have the binding object, which synchronizes the data between those two things. And typically, that's kind of handled for you. You may actually be doing some reformatting of data along the way, so using a converter. And we'll talk about converters later on as well. So at a very, very high level, this is sort of how it looks, right? You have your binding source, which have implemented dependency properties and notify property changed. And then you're using your binding object to send your updates from your from your binding source to your binding target that has actually bound itself to the binding object that's getting its data from the binding source. Now, those that data can come in a number of different ways, and we'll talk about what those ways can be. It can be one-time, one-way, or two-way. And optionally, you can, as that data is moving from the binding source to the binding target, you can do some conversion on it using a converter. And that can be quite useful, especially in views. So for instance, you could bind the visibility property in a view somewhere, in a object on a screen or a control on a screen somewhere to a Boolean in your data source. And that's not an obvious thing, but once you use a converter, it actually becomes quite obvious. So there are two ways to define the source object for a data binding. You can use the data context property. In that case, you're binding to a type that implements the iNotify property changed, and you're setting that binding for that element and for all the child elements. And so that's a pretty straightforward thing. We'll see how that works in a couple of seconds. And you can also use the item source property of a list control. And there you must bind to a type that implements the iNotify collection changed. And if you're using an observable collection, for instance, that's already built in, and so it's already implemented. Not a lot of work for you to do there. and items contained by that collection must implement the iNotify property change. As you can imagine, a specific item within a collection, if a change happens, then it bubbles up, and then that change is then reflected and sent on and propagated to the view. So let's look a little bit what's going on under the hood. And we can talk about dependency properties and dependency objects. A dependency property is a special type of property. They can be data bound, and that's essentially what we're talking about here. And that's sort of the magic behind MVVM as a pattern comes from this sort of magic, if you want to call it that, that's been implemented within XAML. So you have a dependency object. In this case, in the example we have on screen here, the dependency object is the text block control, and the dependency property is the text property within that text block control. And then you have some binding markup extension. In this case, we're binding to something called description. And that is coming from somewhere, and we'll talk about where that's coming from in a couple seconds. That's your data context. You also might want to use a data converter. And so when you bind a target to a source that are different types. So for instance, if you want a control to be visible or invisible based on whether a property in your data source is true or false, you can't use that in the visibility, because visibility requires the visibility type. And so the way you get around that is by defining a value converter, and so you can, and the way you do that is by implementing the iValue converter, defining a class that defines or implements the iValue converter, and then you implement the convert to convert from the source to the target. And then if you want to go the other way, if it's a two-way, you might want to convert back that converts. So for instance, if I wanted to convert from visibility, I'm not sure if that makes sense, but if you want to convert from visibility to Boolean, you could do that again via the convert back method. By implementing these methods, you create a mapping between these two types. That's essentially what you're doing in that method. There is also the concept of a binding mode, and there are three key modes that you need to think about. And it is important to the performance of your app that you implement only the mode that you require. So the one-time mode is populating or moving the data from the binding object to the binding target once and once only. When the page, when that model is loaded on a page load, is when you would see that happening. And then even if the object changes or the source changes, then the view does not change. And so you're making the assumption that your source either is not going to change, or if it changes, you don't care. You only want that to happen once. And of course, that's pretty lightweight performance-wise, because it only happens once at page load time. The one-way change is where the view changes only in the target. So for instance, if I have something that's happening only in one direction, so if I have data that's coming from the source to the target, but the end user cannot change that data, or there's no way for that data to change in the view, then I would use a one-way binding mode, because since it can't be changed, we don't need the extra overhead of monitoring whether it has changed, because we know it will never change, and so we just won't take advantage. We won't implement that. And then there's obviously the two-way binding mode, and this is where the source source is sent to the view and bound to the view, and also the end user in some way may be able to manipulate that, or for whatever reason the target control may change, and so you want to propagate that back to the view model and then on perhaps to the data source, and so that would have to be two-way. And that's done using the mode property. It's here you can see where this image control has mode of one time. And so I'm defining the image on this screen is bound to some data source somewhere, but it's only bringing it in once on page load time, because even if it changes, I don't care. It's just an image that I'm going to define. There are a couple of other binding options that you may want to keep in mind. These are perhaps a little bit more advanced, but handy if you need them, and so keep them in mind. So you can use more advanced property paths that instead of setting the source just the property of the data context, you can actually chain together properties to dig deeper into the object that you're binding to. And so that makes it handier and it makes it easier. You can set the data context once and then do the binding using that binding method. You can also use the string format property to format text within the data binding. And so if rather than just taking the data that's coming directly from your binding, you may want to bind to, may want to add some additional text or what have you to that binding, you would use the string format. So for instance, in this case, we're binding to the coupon expiration date, but rather than just showing the actual date in this text block, I would show the word expiration date, colon, and then the date would follow that. And so I can add some additional text related to that. So enough talking about this in the abstract. Let's actually dive in and have a look at that code. I'm going to switch to Visual Studio here. And let me bring up Visual Studio. I'm going to use Windows Phone 8. And it's still running, so let me stop that. OK, so let me bring up the recipe detail page XAML. And so here, you may remember this page. We're not seeing any design time data, but you can see this is the page that we were looking at earlier. Now, you may have noticed that when we had this page open, in production, we actually saw the title of the recipe as one of the pivot pages. Then we saw another page that had ingredients, and then there was another page that had my pictures. Remember, we took a picture earlier and added it to that list. And you can see here that there are ways to do that. Let me see if I can find that first. So we have a pivot control. There's the pivot, and there's the title of the pivot, and somewhere here, here's the pivot item. The first pivot item has the text. Let me click on it. And you can see that as I click on it, it's actually showing that there is another pivot item here, but it's not showing any text there because that pivot item is bound to title. And so the title of the recipe will be bound there, and that's going to come from whatever my data context is, and we'll see that in a couple of seconds. We also had, for instance, let me see if I can find that. Let me click on it. Here it is. If I click on it, you may remember that there was an actual image of the recipe. And so here I'm binding to background image. And I'm doing all the standard stuff to the image, but I'm binding that. And so we can't see it, but in production time, it will bind that and bring that data in. And then finally, at the bottom, you'll see prep time. And then prep time, beside that is another text block that is bound to prep time. You can see that there. There's nothing there, but when we run this, you will see that. If I come from recipe detail page.xaml, if I look at the code behind here, you'll see that, let me see if I can find it here. Let me just use drop down. You can see the navigate to recipe method. You can see here is where I'm defining my data context. And so I'm finding the item, which is whatever recipe I may have found, and I'm pulling that in. And then I'm setting my data context for that pivot to be item. And then I'm doing a bunch of other things. But the data context is the important thing. Now, when is this navigate to recipe being called? Well, it's being called just above here on the on-navigated to. Essentially what's happening is I'm not going to go through all of this, but essentially what's happening is I'm pulling in my data, pulling in my recipe, and once I have that recipe and I know that my recipe is ready to go, that's when I would use the navigate to recipe. So once I have the data in memory and available to me and it's in my data source, then I call the navigate to recipe, I set my data context, and then that recipe gets displayed immediately on screen. And so that's typically what you would do. So what we've seen here is the view, right? This is my view, the UI. I'm doing all the binding. There's no code behind to get that data. The code behind is to bring the data in, but the actual view itself is being bound to stuff coming from somewhere. So where's that somewhere? That's in the view model. And so let's go have a look at that. That view model is in my recipe data source. And so let's see if I can find that here. If I look at my recipe data source, I can find my, let me find my, actually, let me come back to my recipe detail page, and you'll see that the item there, as I hover over it, is actually an instantiation of recipe data item class. And so if I come to recipe data source and find recipe data item, you'll see that in recipe data item I have a bunch of things, and one of them is prep time, but you'll notice that things like image is not there and title is not there, and you'll see that that's actually coming from the base class, which is in recipe data common. And so if I come back to recipe data common, you'll see that here I am defining, let me see if I can find it. Here's title, right? So here's my title, and defining my title, and then somewhere down here is my image path. Here it is, background image, and that's defined using my image path, and so on. So that's essentially my view model. All of that is happening on the go. So we've seen the view model. We can actually look at what's going on behind that. If I come back to my bindable base, this is actually, come back here, you'll see that recipe data common. So we saw recipe data item inherits from recipe data common, and recipe data common is inheriting from or inheriting from bindable base. And so here there's some interesting stuff going on here. And so this is typically every standard Windows app uses the bindable base. It just makes things a lot easier for you, and so you'll get this pretty much automatically if you're using one of the standard Visual Studio templates. And so there's some handy methods here. One is the set property method, and the other one is the on property changed method. And so you'll see here that the bindable base has that I notify property changed and implements the property changed event handler, and so it does all of that good stuff for you. And so when a property changes, that just happens and propagates back and forth between your data source and what you're seeing on screen. So sorry, not from your data source, but from your view model, which then grabs it from the data source. But in this case, we're just talking about view model. So your view model will grab the data. When that data changes, you'll see that on property change will get triggered, and then any event handler that is bound to that, that is listening on that, will then get that change immediately. And so that's where the magic of binding takes place. I think we'll go back to the slides and dive into that a little bit deeper. So now we have a pretty good understanding of how data binding works. Let's talk a little bit more about actual view models. So view model is a class that acts as a binding source, and so this is loosely coupled to a view. Typically, you do have a one-to-one between a view and a view model. It's not required. You may often have a view that has multiple view models. So for instance, if you had a view that had an order and the order details, those might be two different view models. But typically, most views will have one view model attached to it. And the view model exposes properties for binding, and that's what your view would bind to, and implements the iNotify property change, as we saw earlier, and raises the property changed event whenever a property is set. So once you do this set, it automatically triggers a property change. And that's where you would include your business logic. And by doing that, by moving your business logic out of your view into your view model, that means that you can test that. You can have unit testing. It's much easier to maintain. Hopefully, less bugs as a result. And then you would use your view model to handle all the persistence by sending that off to your data model, which we talked about earlier. So if we look at a view model example here, you can see here, and this is the same whether it's Windows 8 or Windows Phone. It's pretty much the same. Here I have my item view model, as I said, implements the iNotify property changed. I may have a string, and anytime the string is set, it calls the notify property changed, tells it which one is changed, and the notify property changed then grabs that event handler and triggers that event handler so that the view that needs that change is immediately sees that reflected. The iNotify property change binds the source. This is something that's useful in one-way or two-way binding. If you're using one or two-way binding, then you need to implement the iNotify property change. If you're doing one-time binding, that's the case where your view model is, or your view rather, is bound and only seeing that binding one time at page load time, then you don't have to worry about the iNotify property change. It's not required. As you can imagine, even if it changes, it's not going to trigger anyway, so you need to worry about it. So you fire the property change whenever the value of a public property changes, and the runtime framework basically handles all of this stuff behind the scenes to update any of the bound UI elements that are in your view so that they do that. And then, and I mentioned this already, the one-time binding doesn't require that. Now, we've been talking about single properties, but you can also do the same thing with lists. In this, pretty much the same way, there's two ways to bind collections of data. You can extend the observable collection, and when you have the observable collection, you get that iNotify collection changed automatically, or you can implement an iList and an iNotify collection change. Depends on what you're doing in the scenario, but you can do it either way. Item in the collection, the items within that collection. So the collection itself needs to implement the iNotify collection changed, and then the items within the collection have to implement the iNotify property changed. As you can imagine, that's sort of how it bubbles up. In the items panel of an item, you're bound to individual items in the collection. So essentially, it's doing all of that work for you. One other item that is kind of handy and helps to move code out of your view and into your view model is commands. Essentially, that's a method where rather than binding to data, you're binding to a method. And so this is a good way. So for instance, you would attach or bind a button to a command, and by doing that, anytime the button is clicked, then the command is triggered, and the command would then be in the view model rather than in the code behind of your view. And so it's basically taken care of for you. The view notifies the code and some action happens. And so again, moving your your code from your view to your view model makes it more portable, makes it more maintainable, makes it more testable. Generally, it's a good thing. And the way you do that is by implementing the iCommand interface. The code runs whenever the command is invoked. There's a can execute, so you can use this, for instance, to check if a command is enabled or not. And so, for instance, you can use that check to enable or gray out a button or make a button visible or invisible. If a command is not enabled, you may want that button to not appear or to be grayed out so the end user can't click it. And you may, behind the scenes, depending on what happens with your data, change that can execute change, and so there is a can execute changed event that gets raised, and that's when you would handle some of that enabling and disabling of controls on the screen. If we look at a command example here, here is my XAML on screen, or a snippet of XAML on screen for a button, and so the content of the button says say hello, and rather than handling an on-click event that would then be in my code behind, I now have a command which is bound to the hello world command. The hello world command is in my class, which is my view, and then you can see here at the bottom right, here's my hello world command, which would be in my view model, and has implemented my can execute and an execute method, and also has triggered the can execute changed event, which has not been defined here. But in this case, can execute is always true, so it doesn't matter if it's changed. And so whenever this command is triggered, it's just going to pop up a message box that says hello world. And the way I would bind to this hello world command is by, in my code behind for my XAML page, on navigated to, I'm setting my context to my view model, and my view model is defining my hello world command and returning my command. And so by hooking all that up, I'm essentially moving my code out of my view, out of my code behind into my view model, where I can manage it a little bit better. I think we're going to stop there because this is sort of, like I said, it's sort of the basis for the next section, where we're going to talk about MVVM. And MVVM, as you can imagine, the VM part of MVVM is strongly related to binding and view models. It is a view model. So let's just recap. By binding, you're greatly reducing the amount of code that's required to synchronize your app data to the data that you're seeing in the view. Essentially, you're moving your code out of your view and code behind into your view model, where it can be managed and maintained and more easily tested. The XAML binding engine does all of the work, or most of the work, for you. All you need to do is bind and make sure that you implement certain interfaces. And you would use the binding markup extensions to link to the properties of your XAML elements. So any XAML control that is a framework element, almost all of them that I can think of, those inherit from dependency object, and you can use all of those. You need to make sure you set your data context or your item source property when you're data binding. You want to do that after your data is loaded, so you don't get a lot of triggers as your data is changing. You would do it once and have that happen all at once. And you implement your iNotify property change so that as your data changes in your view model, your view reflects that immediately. You can also use converters to convert from a different source and target type, and that's handy for the typical one that I see all the time is binding Boolean to visibility. There's others as well, but that's the one that I see quite often. Properties in the binding path can be changed together, so you can dig and go deeper into a particular object that might be a container of other objects. And keep in mind which binding mode is best for your property. Two-way will always work, but also has a performance impact. Not a lot, but it's enough that you know, if you only need a binding to be one time, it doesn't make sense to use one-way or two-way. So think about that when you're implementing. And then also use commands. Try to use commands rather than code behind in your views. By using commands, you move your code, that code behind, into your view model, or at least into the source code for your view model, and that means no event handling is happening in your view. That means it's easier to test, it's easier to maintain, and all that good stuff. And most importantly, for our purposes, it's much easier to reuse that stuff. I don't see any questions up, so we're going to pause there. Frank, are we going to do a 10-minute pause? 10-minute pause is what we're going to, I'm getting the thumbs up, so 10-minute pause. We're going to take 10-minute pause, and then we'll come back and we'll dig into model, view model, or MVVM. Thanks, grab a coffee, and we'll be back in 10 minutes. All right, welcome back. I'm having fun. I hope you are as well. We've talked about comparing Windows Phone and Windows 8, and we sort of had lightly touched on some of the things you can do to reuse your code. Now we're going to dive into MVVM, which is a pattern. And so that's sort of the first step in building your app in such a way that you can maximize your code reuse. There are other things that we'll talk about later, but the first step, I think, is to separate out the various concerns among your app. let's talk about that in a couple seconds. First things first, I did want to give another shout out to my colleagues that have been kind enough to help me on this event. I think Jaime and Nisha are still online and answering all those great questions that you guys are asking. Please continue to ask the questions. Jaime and Nisha will continue to answer them. Their Twitter handles are up on the screen there, so hopefully if you have questions for them after the fact, please follow them on Twitter. I know they like to see those you've been followed messages. And also I'm thinking Drew mentioned he might join as well, so hopefully you might see him answering questions as well. One of the things, I'm actually going to switch demo code this time. I'm going to use something called Photo Manager or Pix Presenter. And that's, if you want to get to that, if you want to follow along, I've actually bundled up all the resources for this course into one bit.ly bundle. So you can get to that with bit.ly/build for both. You can see that in the bottom right-hand corner, capital B, capital F, capital B again. And that will allow you to get to all of the various resources related to this event. Okay, so what are we going to talk about? So the first thing is, clearly, MVVM is something that many developers are using now, both on Windows Phone and Windows 8, and before that on Silverlight and WPF and so on. The whole idea of binding sort of brought that about, I think. There's no way we could go deep on MVVM. We would probably take a full-day course to walk you through all of the various capabilities of MVVM. What I did want to do is sort of give you a feel for it, and so we'll give you an introduction to MVVM, talk about the architecture and what it means and how it works. We'll talk about some of the pros and cons, and then we'll talk about, once you are in MVVM, what are some of the things that you can do to share code, share your M and VM, not the V part, but the M and VM part of the MVVM between projects within a particular solution, between platforms, in this case, between Windows 8 and Windows Phone 8. We'll talk about some of the best practices. And we'll also touch on there are many third-party libraries that are available that help you with all sorts of additional tooling for MVVM. They're not strictly required, but they can be quite useful. And there are some, there's one in particular that many people are using, and so we'll talk about that towards the end. So let's start with a quick introduction to MVVM. As the name implies, and as I've said before, it's a software architectural pattern. Like many patterns, it's basically there to promote code reuse and separating your concerns, in this case, your data from your business logic, from your view logic, or your views. The MVVM app is divided into three main parts, as the name implies: the model, which stores and maintains the program data; the view, which presents the data, it's all about the UI and receives any user input and then manages what to do with that; and then the view model, that is the interface that binds the data to the views, and so it's kind of important. Everything is very loosely coupled. You may find, or you may be tempted to couple views with data models, or one view model to another view model. I would say resist that temptation and try and keep everything as loosely coupled as possible. You will find that will make your code much more maintainable, and it will also make your code more testable, and you'll stay away from the spaghetti code. Okay, so just as a quick, again, this is a oversimplified architecture diagram, but I think will give you a pretty good idea of how MVVM works. At the bottom there is the model, or the data model. And that is, again, what manages your data. And typically, your view models would be using the data model to retrieve data, and then would use data binding to send that data into your view. The view itself might use commands to let the view model know that the end user has requested some sort of manipulation of data or something along those lines, or has triggered some event. And then there are also events and messages that you may use along the way. We'll talk about some of those later. You may sometimes, in this case, you can see that there's a one-to-one correspondence between views and view models. That is often the case, but does not necessarily have to be the case. And you may often find that there are more than one view model on a screen, or on a view rather. And in that case, you may want to communicate between view models. And the way you would do that is using messages and callbacks, that sort of thing. So we'll talk a little bit about that later on. So the pros and cons, not every app needs to use MVVM. There are, if you're building a very simple throwaway app, then probably you don't need to use MVVM. If, on the other hand, you are using, if you have any sort of reasonable complexity to your app, you will find that MVVM will make your job easier. In particular, and the stuff we're talking about today is about code reuse across platforms. MVVM does make that a lot easier because you are actually moving some of that code into an area where you can then modularize it and then split it across files and so on, and then share it across different platform projects and so on. MVVM does make your code reusable. In particular, your model and your view model are reusable across platforms. The code has a very clearly defined structure because of the way it's implemented and because of this certain interfaces that you have to implement. And it's also easier to test a view model using unit tests. It's actually quite difficult to test a view, and as a result, it's also more maintainable. The other thing you can do with a view model is that you can actually implement design time data. We'll see how that works in a couple of minutes. Some of the cons, there is a lot of cut and paste and boilerplate code. So that's just something you get used to, or in some cases you will use some of the third-party libraries that try and minimize that boilerplate code. It may be more powerful than is necessary. If you're building an app that is very simple, that doesn't do very much, doesn't have a lot of data, it's a throwaway app, then don't bother going to the full implementation of MVVM. It's probably not necessary. Also, by having this strong, this decoupling of concerns, you sometimes lose, or you will lose, strong type checking in some cases, and so you will have to deal with that in your code. So once you have implemented MVVM, what do you do with it? How do you share code using MVVM? We're going to talk about some of the details around that. We'll look at portable class libraries. We'll look at also some of the best practices of when using MVVM. We'll include an overview of each of the parts of MVVM, and then we'll talk about data binding, commands, and messages. So the first part is the model. The model, or sometimes called the data model, is where you persist your data. That's where your data is saved in your database, or in local storage. It can be a database, it can be local storage, it can be a settings, any sort of persistence mechanism. And that's what is responsible for your CRUD, your create, retrieve, update, and delete operations on that data. The model should know nothing about the view or the view model. It really should be completely independent, should only handle the data, and by keeping it separate, it will make it much more maintainable and much more usable as a result. It's usually the most portable part of your application. Because you're using code that is very portable, storage, data storage, SQL storage, that sort of thing, it tends to make the data much more portable. Keep in mind, though, that Windows Phone 8 does support a local SQL Server implementation, SQL Server CE. Windows 8 does not have that. On the other hand, if you do need a SQL database, Windows 8 is supported by SQLite, and so you can grab those SQLite libraries, and they're readily available. A quick Bing search, and you'll find those quite easily. Okay, so let's look at an implementation of a model here. Here we have public class common data item. We're defining a data item, and then the getter and setter, and then the automatically generated sample is already there. You can take advantage of this when you're looking at some of the Windows 8 templates. For instance, if you look in data model / /sample data source, you'll see some good sample code that you can reuse here. So here's the get item, the data service that is implementing iData service, and the get item that where you're actually retrieving the data, and so on. So again, I'm not going to go into a lot of detail here, but you can have a look in data model / sample data source to see how all of those are implemented, get and all of the others. Diving in the view, we already talked about this earlier. View is what presents the user with the interface. That's the UI, and it's what the user uses to manipulate that data. An app can have many views. Typically, a view is bound to a view model. Sometimes it's bound to multiple view models, and that's okay. And basically, in MVVM, the view does not handle the user actions. What you're trying to do is move all of those user actions into your view model so that you can test on those actions and so that you can maintain them. It's easier, makes them more portable. I think I've said that more than once today. The view model itself, or the presentation model, is responsible for presenting the data or getting the data to the view. It's what the view binds to, and so it's how the data gets to the view. The data binding does most of the work for you, so we talked about that in the last session, and it's where you implement your business logic. It's completely decoupled from the view. Your view should never be calling directly into your view model, and vice versa. Developers working on the view model while designers work on the view, and that's why design time data on your view model and your view can be quite handy, especially for your designers. Again, an app can have many view models. Usually it's a one-to-one correspondence between views, not required, but usually. And a view model is linked to a view by sending the data context. It's really as simple as that. And so here we see an implementation of the main view model deriving from view model base. And it's setting the data source. There's your title property, and then you have your getter and setter, and you might have a constructor as well. And then this is where you would implement all of that. I'm going to jump ahead here. So as I mentioned, I'm actually switching to a different demo. In the past few sessions, we've been using the cookbook sample. In this session, we're going to use the photo manager or Pix presenter that's readily available. It's in that resource bit.ly link that I showed you earlier. And I have this sort of architecture diagram of how it's implemented, and we'll see this in a few seconds when we look at the actual solution. But we have one solution that implements multiple projects. There's photomanager.win8 and photomanager.wp8, and those are actually the apps that are implemented. Obviously, Win8 is the Windows 8 one, and WP8 is the Windows Phone 8 one. And then those actually also have class libraries, are referencing photomanager.core.win8 and photomanager.wp8, and then those are referencing shared, which is shared across all of those. So as much as possible, you want to share as much of the code as possible, and then there's certain things that are platform specific, and then of course you have the actual app themselves. And so it's a really good implementation of MVVM, so I thought it would be a really good one to use to show you. So let's actually dive in. I'm going to switch over to Visual Studio. And this time, as I said, I'm going to bring up, let me bring up Photo Manager. And so here you can see I have Photo Manager, which is, if I drill into that, I have photomanager.win8 and photomanager.wp8. Then I have Photo Manager Core, which has photomanager core.win8, core photomanager.wp8, and then we'll ignore SQLite for now, but you'll see that Photo Manager Shared has a bunch of files that are shared across both implementations because for whatever reason that code is shareable. And so let's start at the view layer and then work our way down from the view to the view model to the data model. And so let me go to Photo Manager. So I've brought that up. I'm going to go to Album. Here's my album page. This is my XAML. And so you can see here, and obviously this is the Win8 XAML, as obviously is pretty evident from the file itself. And you'll see here that I'm setting my context. My data context is actually binding to something. It's binding to album, and the source for my data context is actually something called a static resource called locator. And so if we look at, let me find app.xaml, and you'll see app.xaml, there's my static resource. These are my application resources. My static resources is using something called ViewModel locator. And so if I find ViewModel locator, there it is. You'll see, if I come up at the top, you'll see ViewModel locator is actually a partial class that's implementing a ViewModel locator. And it does mean that your code is separated, but it does also mean that I can actually have a ViewModel locator for Windows 8 and a ViewModel locator for Windows Phone 8. And so if we look at the ViewModel locator for Windows 8, and you see that that is doing some additional, is adding some additional view models. And so here, when we bound to album, by binding to album, that means I was able to find the WinAlbum page view model. And by doing that, I'm actually creating my WinAlbum page view model. And so the next step then would be to actually look at WinAlbum page view model. Now, that's my view model, so let's go and bring that up. WinAlbum page view model. And so a couple of things going on here. My page view model, here it is implementing album page view model, and we can go and look at that as well. But it also gives me some additional things. So it's giving me it's creating some design time data, which is useful. And you saw that when I was looking at my album page. You can actually see in the bottom left-hand corner here that my, even though my screen is in design time, just notice it's got some typos there. Even though it's in design time, I'm actually seeing some data, and that would make it easier for my designer to actually make changes and get a better sense for how things would look with real data. And so let's actually look at what's going on here. You'll see that there are some methods that have been implemented. You can see I have a share picture method that has been implemented, and as you can imagine, that's using, it's saving that picture somewhere where it can then be shared. Posting to Facebook, it's using the web authentication and using a Facebook helper class to actually log in to Facebook and actually post whatever it is we want to post, perhaps a photo or a status update to Facebook. And there's my save picture and load picture data that have all been implemented. So you'll see here that that's actually implemented. Let me actually go to my album page view model, and that there actually has, I think you can see some virtual methods here. So navigate to selected picture there is a virtual model, a virtual method. Thank you. It always returns false, and so by returning false, I can actually tell whether the implementation is actually implemented and overridden that or not. And so if I go back to my album page view model, to my WinAlbum page view model, you'll see that it is implemented and returns true, and that's how I know it's been implemented. So it's kind of handy. Now we have all of that defined. Now that data needs to come from somewhere, and so that data comes from my data class, and the data class is in something called data source. If I look at data source, let me go to the top here. You'll see the data source is, again, a partial class. By defining it as a partial class, I can have my data source.cs, which can be shared across both Windows Phone and Windows 8. And then I would have a data source partial class that would be my Windows 8 data source that gives me some additional Windows 8 specific stuff, or my data source .Windows Phone 8, which would give me my platform specific Windows Phone 8 stuff. And as a result, it does make it easier for me to separate out the platform specific stuff and still share as much as possible. Now, of course, as you can imagine, because it's a partial class, that's defined across multiple files. In this case, it's 2 files. And so it does make it a little bit more difficult to navigate. Fortunately, Visual Studio does a pretty good job of helping me with that. So for instance, you'll notice that in the drop down here, you'll see some of the methods here are bolded and others are sort of grayed out. The grayed out ones are the ones that are in the other file that would be implemented. So if I click on them, it will actually take me, you'll notice it actually took me to datasource.win8.cs, and here's my load folders there. And so load folders is Windows 8 specific. For whatever reason, it's loading that specifically for Windows 8. And so as a result, that Windows 8 specific stuff is isolated into a Windows 8 specific file. And as a result, I can use the datasource.cs across both Windows 8 and Windows Phone. And then if I look, well, I don't have it up right now, but if I look, you would see that there is a datasource.wp8.cs, which would also be a partial class, but would only be used in the Windows Phone 8 project. Hopefully I'm making a little bit of sense. If not, please ask your questions. I know that Nisha and Jaime be more than happy to answer those. Okay, let's come back to our slides here. And continue on and talk about some of the things that are going on here. So we talked about data binding. Data binding is critical. It's the whole MVVM pattern is kind of based on that. And the binding is basically what links the view to the view model. We talked about some of these things, the advantages and so on. Very important stuff, so keep that in mind. Commanding, we also talked about in MVVM, the commands let the view tell the view model what's going on. The user's taken some sort of action, and so I want to do something as a result of that action. As a result, but I move that code out of the view and into my view model. We've already talked about some of these commands, so I may actually skip this so that we can gain back some of the time. We talked about, actually we didn't talk about messages, so let's continue on with messages. So messages are a way to send information between objects. In particular, you could send messages between 2 view models, for instance. And so, again, the scenario would be, let's say I had a view that had an order and order details on the same view. And so as the end user switches from order to order, I want to tell the order details view model that it also needs to bring up the details for whatever order the end user has selected, either by search or by browsing or what have you. And so I might use a message to send anytime the end user has changed order. I would send a message to the order details view model to do that. So there's a sender and receiver, or you might even describe them as a subscriber and a publisher. And it's basically really useful for communicating between view models. Often there's a callback for when the receiver is done handling a message, so you can take advantage of that. There are no built-in APIs for that, so it can get a little bit difficult to do that. On the other hand, there are many MVVM libraries out there that help you with that and give support for that. In particular, MVVM Lite, for instance, has a messenger object that you can take advantage of. And so basically, messages are important, and so let's talk about how those are implemented. In this case, I'm just using the generic here. I'm implementing my base view model here and implementing the iMessenger interface. And then I have a publish and subscribe and unsubscribe method. So basically, I'm publishing a message, and then any view model that may have subscribed to that message would then get that message by implementing that. This is obviously much easier when we use, in this case, we're using the MVVM light messaging API. And so it makes it a little bit easier to implement, a little bit easier to read the code. And so I urge you to go and have a look. It does make things a little bit easier. And so here I have a message recipient, I have a message type, and then I have some code at the bottom that's sort of managing all that. So if we look at the bottom here, in the bottom left-hand corner, I'm defining recipient, and that recipient I'm newing up a message recipient object or instance, and as a result, that public class, if you look up there, it's actually registering. You see that in the constructor for message recipient, it's registering for a message. Which message? Well, it's registering for my message, and that my message is defined in a different class over in the top right. And that class is a very simple one. It just has a string property called content with a getter and setter. Pretty straightforward stuff. But by registering that message, anytime that message gets sent, I would then execute this code in this registration API that I just did here. In this case, what I'm doing is I'm taking the content from the message and putting that into a message dialog and showing that on screen. So it's essentially a roundabout way of doing my hello world. And so if you see down below, up above in the message recipient class, I've registered for a message. Down below, you see where perhaps in some other part of my code, I'm actually sending that message. And so messenger.default.send my message, and so I'm putting that message on the message bus there, newing up my message, and I'm giving it some content. In this case, it's hello world. And so as soon as I do that, my message recipient, my underscore recipient instance is going to get that and is going to show a message dialog with that content. And so basically bring that up on screen. Again, this is sort of a trivial example, but it's a really good illustration of how you can send a message to a view model, or how you can send a message from one part of your code to another part of your code without actually tightly coupling that code together. By doing it this way, you're keeping your code loosely coupled, and so it's much more reusable, much more maintainable, much more testable, and so on. All the good stuff. So once you've done that, once you've implemented MVVM, then you need to sort of package that up so that you can share it among the various platforms. And the way you would do that is using the portable class library. And by sharing, essentially what that does is it essentially defines a library, DLL, that limits itself to certain .NET APIs, a limited set. And the limited set, you define what that limited set is. I'll show you what that is in a few minutes. And by doing that, I'm defining my portable class library. It's managed code. Oh, I should mention portable class libraries are only available, unfortunately, in the non-express editions of Visual Studio 2012. So you would only be able to use it in a Visual Studio Standard or Pro and above. So some best practices for MVVM. These are kind of generic. So as you get into MVVM, you'll start adopting these to your own needs. Design your apps for cross-platform portability. So even if you are building an app today that would be only Windows Phone 8, keep in mind that at some point you may decide to make it a Windows 8 app. And if you design using MVVM today, it will make it much easier for you to port that app, or to at least extend that app, probably with very little effort, make that app also a Windows 8 app, in the same way that this Photo Manager app has separated itself out and made itself both Windows Phone and Windows 8 with a whole high degree of code reuse. Separate your concerns. So again, keep your concerns separate between data, view, and ViewModel, and plan for upgrades by using MVVM, or if you choose another loosely coupled architecture, MVC or what have you. MVVM just happens to be the one that most people are using, whether they're building Windows Phone or Windows Phone 8, Windows Phone 8 or Windows 8 applications. Data binding does eliminate a lot of the code in the code behind. It can't eliminate all of it, unfortunately, but some code behind is fine. Don't get too hung up on trying to remove all of your code behind. Sometimes it's just easier to do it that way. But try and use, wherever possible, use data binding and commands to replace as much of your code as possible. Avoid binding to large collection multiple times on the same XAML page, because you're going to get obviously some huge performance penalties for doing that. Using duplicate bindings to different pages, it's just going to hit you, and you're going to have issues with that. Keep in mind that binding does incur memory and CPU overhead, so be cognizant of that. Be careful that you're not binding too much data to a page, and try and limit yourself as much as possible. Large collections bound to list controls should be virtualized. So don't bind these large collections and have them all in memory at one time. Use the virtualizing stack panel in place of the stack panel, and by doing that, hopefully you will be able to page your data in as required. You can narrow the scope of the data context within the XAML document. The example here is if you have a car object that exposes an engine object named car engine, then you can bind directly to mycar.carEngine and hopefully avoiding these long property paths where required. So just abstract that out in the way that you would need it. It's going to depend on your own scenarios. And so keep that in mind. As I mentioned, as you're building MVVM, there is no requirement when you build MVVM to actually use a third-party library. There is no MVVM implementation directly embedded within any of the Windows or Windows Phone templates. There's the beginning of some, but it's not a fully implemented MVVM. And so there are actually many third-party MVVM frameworks out there, many of them open source. And so this is a quick snapshot. In fact, it's not the whole snapshot. I only grabbed the top half. I just went to Wikipedia and I grabbed a screen grab of the top, I don't know, 15 or 20 MVVM open source frameworks. There's many of them available. Some of them may be more suited to what you're doing than others. Some of them may be more suited to larger projects, some of them lighter projects. The one that I've seen used quite often lately is called MVVM Lite. This was created by Galasoft, a smart guy named Laurent Bugnot, based in Switzerland, working for IdentityMine. And he provides you a bunch of, it's open source, so you can just go grab it on codeplex.com at mvvmlite.codeplex.com. And it's a library that includes Visual Studio templates. It supports a lightweight implementation of the MVVM pattern. It's suitable for medium to large projects. I know some people prefer not to use third-party. They just don't want to take the dependency. And so it's really up to you whether you decide to do that. Probably when you're getting started with MVVM, you may want to get started using a third-party library, and then over time you may decide that that's not the way you want to do it. But certainly give it a look. MVVM Lite, I'm not endorsing it. It's one that I know many people use, but it's not the only one out there. So please go and have a look at that. So quickly to recap, the MVVM model, as the name implies, model, view model. The model stores the persistent data. The view gives you your view and allows the end user to manipulate that data. And the view model presents the data to the view and responds to user actions. MVVM, super, super useful in Windows Phone and Windows 8, and before that in Silverlight and WPF. It's been around for quite some time. And it does allow you to make it easier to build view models that are a little bit more structured, a little bit more maintainable, a little bit more modular, and it works across. There's a number of ways to share those MVVM objects, your models and your view models. We talked about portable class libraries. There are others. We're going to talk about those in the next session. Things like inheritance, partial classes, shared code files, conditional block, if conditional blocks, and so on. So we finished a little early. I thought we were going to go long, and so I went a little bit fast, and now I've actually finished a little early. So I think we're going to pause there, and I don't see any questions on the screen, but if you do have questions, please post them to the chat screen, and Nisha and Jaime will answer those, and we'll come back in 10 minutes or so with the final session, and there we're going to get into the nitty-gritty, where we'll talk about some various different code sharing techniques and tips. So go grab another coffee and come back, and we'll be back in 10 minutes or so. All right, welcome back. So we're in the home stretch now. We've talked about, we've compared Windows 8, Windows Phone, and we've now given you the basics around data binding and view models and MVVM. Now we're going to sort of wrap all that together and talk about how you can share code between Windows 8 and Windows Phone 8 in Visual Studio. And so this is the last thing. We'll end in about half hour or so. I did want to give another shout out to my partners in crime, Jaime and Nisha, who have been steady answering questions in the chat room. Please do go follow them on Twitter. Both of them are super smart on Windows 8, and Jaime actually has spent a lot of time on Windows Phone as well. So please do that. And I don't know if Drew has joined us yet, but he mentioned he might join as well. So you might want to follow him as well. Okay, so what are we going to talk about in this session? So like I said, we're going to try and wrap all of the stuff that we've talked about over the past 3.5 hours into some reuse techniques. We'll talk about portable class libraries. We'll talk about sharing of source code between projects and between projects in a platform. We'll also talk about inheritance, conditional compilation using the pound if block, conditional blocks, and then finally partial classes and partial methods. We saw some of those in the previous session, but we'll go into that in a little bit more depth and maybe see some more demos as well. So let's start with portable class libraries. Again, the portable class library, we've mentioned this already a couple of times. It's a portable class library project template in Visual Studio 2012. You can build in either C# or Visual Basic. It is managed code, and it's really good for building cross-platform DLLs that are pure business logic, right? You don't put UI into those because, again, you don't want to reuse UI, and you can't, in fact. It is only managed code. You would have a single code base for Windows and Windows Phone, and in fact, you can also include Silverlight or Xbox if you're building for those platforms as well. We're going to focus on Windows and Windows Phone. Only shared assemblies are available for use, and so it's mostly restricted to the system namespace. There's others as well, but mostly restricted there. And overall, it's limited, but the nice thing is that it gives you this portable, modular, encapsulated code that you can use among different platforms, and in our case, between Windows Phone and Windows 8. So let's dive in. Let me just, rather than talk about it, let's actually look at portable class library. So let me get into Visual Studio, and I will get into, and actually this is another project which I don't have open. Let me just quickly open that. I guess I should have been prepared. Sorry about that. So this is a portable class library. It's a very, very simple example that allows me to illustrate what you can do with a portable class library. It sort of reduces the portable class library to its lowest common denominator, where I'll have a portable class library with one method, which is an addition method that will just add two numbers together, and then I'll use that and reference that from both within a Windows 8 and a Windows Phone 8 project, and you'll see how that's pretty straightforward to do. So here's my project. You'll see here, so let me show you how I would create a portable class library. So I'm just going to right-click, add, new project. And so I'm not going to actually do it, but let me just show you that here is the portable class library. I would give it a name and then click OK. And then it would ask me, so what are the target frameworks that you want to include in your portable class library? As long as you have .NET for Windows Store, .NET Windows Phone 7 and higher, probably want .NET Framework and so on. So that's what you would do. And so we've already done this, and I have my reuse.pcl. This is a portable class library. I can open that up, and you'll see in the properties for that library, there's the name of it, and I can see here are the target frameworks that I've actually defined in this portable class library. And so that's all I need, except that I need to define something within that library. And so I have a static class called helper, and in that there's a method called simple addition that takes value 1 and value 2 and returns the addition of that. Not a lot of mind-scratching code there, but it's useful to illustrate the point here in that I have this reusable portable class library, and then I can come into and look at, here is now a Windows 8 code. Let me just bring up the properties here. You can see that here I have an application. It is a Windows Store application. And so when I look at that, I can see that I am actually referencing reuse.pcl. And so by doing that, I can actually take advantage of that. So if I come into my main page.pcl, as soon as I open my main page, as soon as I navigate to that main page, I am going to have this variable here that's going to call reuse.pcl.helper.simpleAddition and add the numbers 2 and 4 together and write those into output. So let's see if that works. It does, but let me just show you what it does there. And so here is my Windows 8 app. The Windows 8 app is going to run, and as soon as it runs, then we can switch back to Visual Studio, and then we can actually see that the output is in my debug window. I think I have too much stuff in memory. Too many Visual Studio projects open, I guess. Let me tab over. No, it's not running yet. Huh. Let me see if I can view my output. Oh, it did. It was running already. So I don't actually have anything on that main page, so I didn't see it. But you can see here that I've actually output the sum, which is 6. Big whoop, right? But the interesting thing there is that I used that DLL, that portable class library, and that is portable code. That exact same DLL can be used on Windows Phone. And so now if I take the Windows Phone app, so there's the reuse.wp8, and so if I come down here, you'll see that this is again an application. It's a Windows Phone 8 application, and similarly there is a main page.xaml. Oops, I didn't mean to open that. But there's also a main page.xaml.cs, and again, it's doing the same thing. As soon as that page is navigated to, it's going to grab reuse.pcl. Again, I am referencing that exact same library, reuse.pcl, and by calling it with same addition, let's just run it. Whoops. Let me just stop that. Let me make my Windows Phone my default startup project. And as soon as I do that, I'll run it again, and you'll see that it works exactly the same way. So when it compiles your AppX or your Zap, whether it's Windows 8 or Windows Phone, it will actually bundle up that project together. So let me set Windows Phone 8. Now when I run that, it should bring up my my emulator here, and it's connecting to the emulator, deploying it, and there's my empty emulator page, and you can see in the bottom left-hand corner the 6. So that Zap file is actually bundled up not just my application, but also the DLL. And that DLL is code compatible between Windows 8 and Windows Phone 8. Again, it's managed code, so we can do that with managed code. And so it gives you everything you need. So Very simple to do, and that same property, the exact same method works across whether I'm doing, again, a simple reusable method, in this case that simple addition method, between Windows 8 and Windows Phone 8, but I could also do the same thing with a data model or a view model and do that. I've been asked to remind you to take a second and choose the best answer in the polls for this session. I'd really appreciate any comments that you might have about this session, things that you liked, that we covered well, and perhaps things that maybe we went too fast over and that we didn't cover as well, and that maybe as we refine the content, we can add that and do that in the next iteration of the content. So again, take a second and choose the best answer in the polls for this session. Okay, let's get back, and we talked about portable class libraries. Let's talk about another simple way of sharing code between projects, which is just sharing the actual source code. So in many cases, you may have source code that you would share that is virtually identical between a Windows Phone project and a Windows 8 project. And of course, you don't want to copy that code, because then if you copy that code, then if you make a change in one, maybe you fix a bug in one, it doesn't get fixed in the other. And so what you want to do is have that identical shared source code between both projects, between multiple projects, between Windows 8 and Windows Phone. It means a single change to a code shows up in all the projects. There is a really easy way in Visual Studio to do that. In other words, or the way to do that is to actually have the code in one project, and then when you add it to a second project, let's say you have it in your Windows 8 project, you would have some shared source file, a .cs file, that you want to share in Windows Phone 8, in a Windows Phone 8 project. You can actually add that source code file to your project using a link rather than copying it over. And basically, when you add it as a link, you're essentially adding that same file. And so when you edit that file, you're also editing it in the Windows 8 file. It's essentially the same file. And so that's really handy. It's a really handy technique, especially obviously when you have code that is virtually identical with it, whether it's Windows Phone or Windows 8. I'll show you some of that in a couple seconds. Another way to do it is to use conditional blocks. This enables or disables code depending on so I'm seeing a question here, directly from Jaime. Hey Jaime, thanks for the question. Any nice sample for sharing HTML, JavaScript app code between Windows 8 and Windows Phone 8? Suppose a hybrid app with a browser inside is needed for Windows Phone. That's I don't have a sample for that right now, but it's a good one. What I'll do is I'll take that and I will try and find you one. I seem to remember seeing one in the sample code, and I'll add that to the resources, so that bit.ly/Windows Phone, bit.ly/build for both. We just take a note of that. HTML, JavaScript. Okay. So in a conditional block, basically you're enabling or disabling pieces of code based on a target platform or a compiler variable. And that variable would define whether my code should be compiled in one code path for Windows Phone and another code path for Windows 8. And we'll show you how that means. So there are specific platform-specific conditional compilation constants. There's netfx_core. When you see that conditional compilation constant, that you know is a Windows 8 code path, and Windows_phone is the compilation constant for Windows Phone. Sorry, Windows Phone 8. This is useful when you have subtle differences between APIs. I would caution you, it can get a little bit hard to understand your code sometimes. And there's different ways to do this. There's better ways, and there's good ways and not so good ways. And so I do have a couple of examples. In this case, here you can see the poundif netfx_core. And so I'm basically using a conditional block and changing my using statement for imaging. For instance, if I wanted to use a bitmap, for instance, the bitmap is in a different namespace, identical code, but it's in a different namespace whether you're in Windows Phone or Windows 8. And so this is a really good use for a conditional block, and it doesn't change your code that much. It's not that hard to understand, pretty easy. This is another example, perfectly legitimate example, but in my mind, it does make the code a little bit harder to read. It's certainly usable, and it is legal code and certainly legitimate code. Here we're using the convert method where if it's not Windows 8, then we're using culture info culture. Otherwise, we're using string language. In my mind, I think a better way of doing this would have been to use to put the entire method signature within that if, else, and if thing. It just would have made it, I think, a little bit easier to understand. So just be careful with that. Again, it does make understanding the code sometimes a little bit difficult. Let's have a look at a demo. Let me switch over to Visual Studio, and we'll have a look. I'm going to use the Photo Manager app again. And so here we do have a portable class library here. You can see we also have some shared code as well. And so if we look at Windows 8 ViewModel, for instance, you can see the C# with the little blue kind of square on it. That's actually telling you that iViewModel.cs is actually used somewhere else. So if I bet you if I come down into Windows Phone, if I can find it, there it is, iViewModel.cs. You'll notice that just shows me as a C#. That file is virtually identical, pointing to the exact same file on disk as this one here, and yet if I change one or the other, that change would then get reflected in both. And so, again, that's a really handy way. If you have code that is virtually identical between Windows Phone and Windows 8, really easy way to do that. The other thing I wanted to show is, let's see, I think I have it loaded already. Here it is, picture.cs. So this is, let's see if I can find it. It's in photomanager.core. Let me see. WP8 data entities. There it is. Okay, so there's the file I'm looking at here. That file, you can see here at the top, I'm using the if netfx core, and if it's Windows 8, then use this using statement. Otherwise, if it's Windows Phone, then use this using statement. And where that's handy is, in this case, the bitmap image, you can see is, I don't know if I can show you both at the same time. No, I guess not. So bitmap image, just bring it back up. The bitmap image is defined in two different namespaces, and so this is just a really handy way of switching between and just making my code a little bit more portable without having to have too much confusion there. So that's a really handy way to do it. And then there's Photo Manager, let's see. Photo Manager. photomanager.wp8, here it is, and here's my Boolean visibility converter. And here we can see here where I have my convert method. This is the same one we saw earlier, and you can see how, looking at the code, it just makes it a little bit harder to understand that is one method signature, and probably a little bit harder to read, maybe a little bit harder to maintain, more apt, here it is again, more apt for me to mess up on this one. And so again, I would caution you to not overuse the pound if statement or conditional blocks. It can make your code a little bit harder to understand. Okay, so let's switch back and talk about some other ways that you can use to share code between projects or between platforms. In particular, one that's really handy, it's been around for a while, this thing called inheritance. Maybe you've heard of it. And so basically, by sharing functionality that is common in a base class and then using platform-specific code in subclasses, you can separate cross-platform features from platform-specific features. And so you can do it a number of different ways. You can make your base class abstract and then implement completely in the platform-specific implementation, or you can put some of the code in the base class and then override or add to it using the subclass. Here is one example here. This is first one. This one is from the album page view model CS file. And so you can see here where I have a album page view model that would have a base class and would have code and would do some interesting stuff. We saw this one earlier. And then I have my win album page view model, which inherits from that and then would then allow me to take advantage of some platform-specific stuff that would be Windows-specific. This is another one. This one is from the main page view model base class. And here you can see we have an abstract class, and so you could never actually define this instance of that. In this case, it just wouldn't make sense to do that. There's not code in there that would make sense. And there's also an abstract method as well. And so in this case, you would want to derive from that and then also override that method so that you did your own method as well. And so navigate it to photo. I think we saw this one earlier as well. So two ways to do that. Let's have a quick look at those in Visual Studio. So here I am back in Photo Manager, and I am looking at
I'm not seeing it.
Oh, okay. Sorry. I guess you're not seeing it yet because I think I left PowerPoint still running. Thanks for that, Barry. Okay, let me try that again. Is that better? Okay, excellent. So let's look at, let's see, I wanted to look at album PageViewModel.cs. And so here you can see the album page view model has a full implementation here, including various properties, and here's a virtual class. I think we saw this one earlier as well, and so on. And then if I wanted to look at the subclass for that, then there is the win album page view model.cs. And so here you can see that I've overridden the navigated. You can see I have my win album page view model, which derives from album page view model, and then I also have overridden that abstract method here. Yeah, so I mean, this is sort of standard inheritance. There's nothing really magic about it. But if you do it in an intelligent way, you can actually separate your code in a way that makes it easier for you then to have a base class that you would use across both Windows Phone and Windows 8. And then you would have a subclass that's specific to Windows Phone and a subclass that's specific to Windows 8. OK. And then the final example here is partial classes. And we've actually seen some of these already. Here you're sharing functionality you have your shared functionality, or the functionality that is shared across multiple platforms. You would put that in one code file, and then you would have a platform-specific code in another code file. And so in this case, we're looking at datamodel.cs, and datamodel.wp8.cs would be the Windows Phone 8 specific data model. And then I might have a datamodel.win8.cs. When it's compiled, all of that gets combined by the compiler into one class. That's why they call them partial classes. They're spread out across multiple files. It is a bit of a problem in that you're spreading those files across multiple files, but as I think we saw earlier, by doing it that way, actually there is some functionality in Visual Studio that makes it easier for you to navigate among the various methods there. You can also have partial methods and use partial methods as a mechanism to separate platform-specific logic. Two parts of the definition and the implementation. Both parts must be in the same partial class, obviously. And if no implementation exists, then the compiler removes all calls to that method. So you have to be careful that you actually implement that properly. And so here is a partial class method here. This is a data model where I have my get folders async, and then I would have my data model.wp8 where my load folders async, which would be perhaps specific to Windows Phone 8 in this case. And I think that's the exact same code in there. So I'm going to stop there and just recap. We've come to the end, but I wanted to quickly recap and hopefully give you a chance to ask some additional questions. Hopefully what you come away with today is some good tips and techniques that you can use to develop apps that will work across both Windows 8 and Windows Phone 8. Even if you're thinking about developing today for just Windows Phone or just Windows 8, take some of these techniques to heart and try and build them into your code today so that you can future-proof your app and make your app available to both Windows 8 or Windows Phone, whatever the case may be. Make sure that you use data binding, and when you do that, do it in such a way that you can extract out your code. Try to have as little code behind in your views as possible. Try to move those views into your view model, your code behind into your view models. That will make your code more modular and more reusable. Consider the MVVM pattern. That MVVM pattern is really handy. Even if you don't use MVVM, certainly separate your data model out because that will make your code reusable as well. The data models are typically the easiest thing to reuse across both Windows Phone and Windows 8, and so take advantage of that. And then use strategies so that you can reuse source code. Some of the ones that we just saw over the past few minutes: portable class libraries, shared source libraries, conditional blocks, inheritance, and then partial classes and partial methods. I've showed this earlier, but let me just show it again. I did compile a bunch of resources, and I've made those available on Bitly. If you go to bit.ly/build for both with a capital B, capital F, and capital B for build for both, you'll see that there's a bunch of links there that will take you to a number of resources that will be very handy, including the source code for both the cookbook as well as the photo manager app. And as well as a number of really handy MSDN articles and other articles, as well as some of the other MVVM third-party libraries. So with that, I will say thank you. Thank you so much for sitting with me for the past 4 hours or so. I certainly have enjoyed it. My voice is about to go, but it's been a lot of fun. If you do have comments, I think we still have the polls available, right, Frank? Please answer those poll questions. We do want to know what you think of this event. Please make sure that you answer the polls and give us any feedback as to were there some things that you liked? Were there some things you didn't like? Were there some things that we missed that you thought should have been included in this event? And so with that, again, thank you very much for attending. My name is Ben Riga. If you want to follow me, look for my page on about.me/ben.riga. And I'll end there and give you 4 minutes back. We ended 4 minutes early. Thank you so much for attending this course.